summary assignment is based. You should have received an email with your instructions. If not, they are all on Vital. So, the important points are on the board. Deadline is midnight on the 27th of April. Please upload your assignment via Vital using your correct module code. So if you're elect 222, go to that one. 273, go to that one. MSc students, please use elect 483. Also, just a warning, the assignment is very slightly different for Year 2s and MSc students, so don't panic if you realise they are different. Year 2, you're going to have to submit in LaTeX. Use the template provided. If you're, for all year groups, if your executive summary is over 2 pages, you will fail. The important thing is to keep it concise. That's the difficulty. That's what's difficult about this assignment, is getting all the important information and presenting it in a really short format. Okay, any questions? Please contact me directly. My email address is up on the board. And with no further ado, enjoy the seminar.
Okay, guys, quiet down, please. Okay, I'm going to hand around the scanner. I want everyone to put their phones away. Okay, you don't need to take photographs of the slides, so you don't need your phones or your cameras out, because they're going to make the slides available to you. Okay, down low. Okay, so I don't want to see any mobiles, I don't want to see any cameras, I don't want to see any iPads. Quiet down. Okay, so we've got 2 speakers today. They're from the Risk Institute, which is in the Department of Engineering. We've got Dr. Patelli and Dr. Kulumzur. Almost. Okay.
So, welcome to my seminar. I'm Eduardo Patelli. I'm from the School of Engineering and member of the Institute for Risk and Uncertainties. My background is in engineering and uncertainty classification. But today I'm going to talk about risk and uncertainty in engineering. So first of all, I would like to present the outline of my talk. So I will start with a very brief definition about risk. So, and then we will move in the second part of this.
Light going on, sorry. I'm struggling to hear you.
Now, please.
Any better? Is it better?
No.
Okay. Okay, I will try to be loud. Okay. Just interrupt me if you cannot hear me. Okay. Okay. So in the second part of this presentation, I'm going to talk about how can we deal with uncertainties and how can we quantify the uncertainties. So, prior to start with this presentation, to define risk, I think everybody of you has his own definition of risk. So, for instance, are you going to bet all your money on the next winner of the Champions League? Probably not, because it's not so obvious who's going to win, right? But there are also other aspects related to risk. For instance, this can also be quite risky activities, right? Stupid. Another risky activities like this climbing, but I'm sure some of you it's totally fine to take this kind of risk, right? Probably for others, no. So you can see there are different definitions of risk. And risk means to quantify the effects of uncertainties on some objective. So there are also other definitions of risk, but what I like most is the last one, that is a way to learning to cope with the uncertainties. So basically, risk is a product between the different components involving different aspects in the definition of risk. So one is quite obvious, is related with the probability of the events, so, or the uncertainties. So here you can see a table that's involving different risk factors. You have a look about this table. There's some, also quite surprising sometimes. So you see that the probability of that related to the nuclear power plant is 1 over 10 billion. It's very low, and very high probability risk factor is related to some disease here, very common. Okay, so this is the first aspect that involved on the risk. It's the probability of the event. But it's not the only one. So the second important factor are the consequences of the event. So one activities can have a very bad consequence, other bad consequence. For instance, if you use your bike and you fall on the bike, probably you won't die. But there are other activities that they can have a very serious, severe consequences. So here is another table that shows the estimated loss of the life expectancy due to different causes. For instance, if you have a man, if you are smoking, you have 2,200 days less expecting day. But also, if you have working dealing with the radiation exposure, you're expected to have a 40 days less of your life. Okay, this table actually is very updated. So, and in fact, I think nowadays it's no different between if you are smoking and you are female, or if you are smoking if you are male. So this is quite old table. But keep in mind that there are some consequences involved in the definition of risk. But from this table, you can immediately recognize one aspect. So obviously, the people, there are a lot of people that are smoking, right? But there are very few people that like to live close to a nuclear power plant. Why? Because for different people, the risk is different. There is also the perception of the risk that's really important. And there are different factors that affect the risk, the perception of the risk. For instance, if the consequence of the event have some catastrophic consequences, or if you are familiar or not with the risk, or if you can control the risk, or if you are exposed voluntary to the risk. If you go climbing because you have chosen to go and climbing, but living in a country close to the outland probably not your own choice. So as you see here, and also it's also important the last one, the origin of the risk. So it's much more acceptable the risk due to some natural events than the risk created by the human, like derived from some installation, technological installation, or some power plants, for example, other installations as well. So how can we deal with risk? So we can use the so-called ALA principle. That means we can reduce the risk as low as reasonable practical. We cannot reduce the risk to zero because this would be too expensive. And you can see here from this table here. So if invest more money, we can reduce the risk, but we have to find a balance between the risk and the cost of the prevention of the risk. But now I will move on the second part of this presentation, when we are to focus on the uncertainties management in engineering. It's important to mention that the analysis and the design in our engineering field are done in the view of the uncertainties, implicitly or implicitly. But it's important to answer to the following questions. Which are the effects of uncertainties and how we can deal with the uncertainties? First of all, there are two different kinds of uncertainties. The so-called reducible uncertainties, they are related to some parameters that are really uncertain. So like the radioactive decay, some the future environmental condition, or some related also to chaotic or stochastic process, like turbulence flow, as shown here on this slide. The second family of uncertainties are so-called reducible or epistemic uncertainties. And these are actually some quantities that can be identified. But for a particular reason, this is not feasible because either it's too costly or you cannot afford. For instance, if the identification of the property of the soil is done usually using some indirect measurement, or when you use some simplified model in order to predict the behavior of your system. So you are introducing some uncertainties. And it's very important that you take into account all these kinds of uncertainties on your design. Because the uncertainties can have very bad consequences, like some failure of some offshore installation, or as you can see here, you probably recognize they can destroy also a nuclear power plant, or again, uncertainties can also be related to some poor maintenance. So here you see some poor fuselage of this airplane, and here the consequence of a train accident occurred in Italy in 2009. So all of these failure or uncertainties are related to some random quantities. And the effect of these random quantities has to be evaluated. And the most general tool to estimate the effect of the uncertainties is so-called Monte Carlo method. Okay. What is Monte Carlo method? It's a computational technique based on the random number. This is the most general tool that you can use it to solve and different aspects, different systems. So it's based on number generated randomly, and then you need to evaluate your system, and then you collect the quantity of interest. The random number generator is a tool that is able to generate a sequence of number with each term is unpredictable. The simplest tool probably is the roulette, but you can also have other tools. So there are also different families of random number, like the true random numbers. From here, for instance, they can derive from the Geiger, or they are the pseudo-random numbers. The random numbers that are used nowadays, they are random numbers generated by a machine, or they are the so-called quasi-random number. The Monte Carlo method is largely used. It's used to solve integral differential equation or system of equation. They are used to simulate random events, like the ground acceleration. For instance, we'll see more details in the second part of the presentation. Or they are used for photography or decision making, but also used in the computer scale. For instance, statements are used based on Monte Carlo or random number. What is important for us, I would like to focus a little bit more on the aspect, is to identify if the system of a component is safe or not.